The universe contains more stars than all the grains of sand on every beach on Earth. With numbers so incomprehensibly vast, the idea that we are utterly alone feels almost arrogant. The math seems to agree, offering compelling odds that other thinking beings should be out there somewhere. Yet when we listen, we hear only silence. When we look, we find only emptiness. This is the heart of the Fermi paradox, the staggering contradiction between the high probability of cosmic company and the complete absence of any proof. It is one of the most profound puzzles ever faced by science. By the end of our exploration, you will understand the most compelling and unsettling explanations for this great silence. From cosmic quarantines to hidden dangers we have barely begun to fathom. We will confront the possibility that advanced civilizations are all around us but utterly invisible, and we will grapple with what their silence might be trying to tell us. Are we truly the first to look up at the stars, or is the universe hiding something from us? This mathematical optimism has a name, and it is perhaps the most famous formula in the search for cosmic neighbors. It is called the Drake equation, conceived by the astronomer Frank Drake in 1961. It is not a true equation in the sense of providing a single, definitive answer. Instead, it is a structured way of thinking, a chain of probabilities that breaks down the vast, overwhelming question of "Are we alone?" into a series of smaller, more manageable questions. Think of it as a cosmic checklist for civilization. The equation begins with something we can observe, the rate at which new stars are born in our galaxy. From there, it asks a cascade of crucial questions. What fraction of those stars have planets? Of those planets, how many orbit within the habitable zone? That Goldilocks region where temperatures are just right for liquid water to exist. This is where the possibility for life as we understand it begins. The next steps are the great unknowns. On a suitable world, how often does life actually arise? And if simple life begins, how often does it evolve into complex, multicellular organisms? Then comes the leap to intelligence, the development of a species capable of curiosity and tool use. Finally, and most critically for our paradox, how many of those intelligent civilizations develop a technology that we could detect, like radio signals or other signatures of their activity, and how long do those detectable signals last? When you string these probabilities together, even using what scientists consider very conservative estimates for each step, the result is rarely zero. Given the hundreds of billions of stars in our Milky Way alone, the math consistently suggests that the galaxy should be humming with activity. It tells us that intelligent, communicative civilizations are not just possible, but statistically likely. This is the foundation of our cosmic optimism, the compelling numerical argument that says we should have company. And yet, when we run the numbers and then look up at the silent sky, we are left staring directly into the heart of the paradox. The equation gives us every reason to expect a cosmic conversation, but reality offers us only a profound and unsettling quiet. This profound contradiction between expectation and observation is what we call the Great Silence. It is not simply that we have not been visited by flying saucers. It is the utter absence of any signal, any artifact, any cosmic footprint we can point to and say, someone else is out there. The question was framed most famously over a casual lunch in 1950. The physicist Enrico Fermi, discussing the high probability of extraterrestrial civilizations with colleagues, posed a deceptively simple question. Where is everybody if they are so likely, he reasoned, why do we see no sign of them? His point was not about physical travel, which faces immense hurdles of distance and time, but about evidence. A civilization only slightly more advanced than ours by perhaps a few centuries or millennia would possess technology we can scarcely imagine. their energy use, their communications, their engineering projects should, in theory, cast shadows we could see across the galaxy. We have been listening intently for those shadows for decades. Since the 1960s, projects like SETI, the search for extraterrestrial intelligence, have scanned the heavens with powerful radio telescopes, sifting through the cosmic static for a pattern, a beacon, a whisper of artificial origin. They have surveyed millions of star systems and frequencies. The result, thus far, is a resonant and unbroken quiet. The paradox, therefore, is not that we lack interstellar travel. It is that we lack any detectable evidence at all, across the entire electromagnetic spectrum and beyond, from a universe that mathematics tells us should be teeming with voices. This silence is not passive. It is an active data point, a message in itself, and as we will see, interpreting what that message means leads us to some of the most startling possibilities about life, intelligence, and our own future. One potential answer to the silence is both elegant and deeply unsettling. It suggests the universe is not empty of intelligence, but full of it, and that we are being deliberately ignored. This is the core of the zoo hypothesis. Picture our planet not as a lonely outpost, but as a protected exhibit within a vast, unseen galactic sanctuary. The idea proposes that technologically advanced civilizations exist all around us, but have collectively agreed to a strict policy of non-interference. They observe us from a distance, much like wildlife biologists observing animals in a nature reserve, careful not to disturb the natural behavior of the subjects. The reasoning behind such a protocol is profound. A more mature galactic community might view contact with a young, developing civilization like ours as inherently harmful. Our culture, our science, our very sense of identity could be shattered or irrevocably altered by the sudden revelation that we are not the pinnacle of creation. This cultural contamination could stunt our natural evolutionary and social development. They might be waiting for us to reach a specific milestone on our own, perhaps the peaceful unification of our own world or the mastery of interstellar travel, before they consider us ready for an introduction. The implications are staggering. It means the Great Silence is not an accident of distance or time, but a deliberate condition, a cosmic quarantine imposed for our own benefit or for the sake of scientific study. It transforms the universe from a lonely desert into a populated gallery where we are the unaware centerpiece. If this hypothesis is true, then every radio signal we send, every probe we launch, is being monitored by silent, unseen curators. Our entire history has unfolded under the gaze of observers who have chosen, for now, to remain in the shadows. This leads us to a darker, more urgent possibility. What if the silence is not protective but predatory? A far more radical idea suggests the silence is woven into the very fabric of our reality. This is the Planetarium Hypothesis. It dares to ask, what if the universe we observe is not the true universe at all? What if the vast, star-filled expanse we study through our telescopes is a sophisticated illusion? A cosmic-scale simulation or projection created by a technology so advanced it is indistinguishable from nature itself. In this scenario, the Great Silence is not a policy of non-interference like the zoo hypothesis. It is a deliberate design feature. The emptiness, the lack of any other civilizations, is programmed into the simulation to give us, its inhabitants, the distinct and powerful impression that we are utterly alone. The evidence is not being hidden. It is simply not part of the rendered reality we are permitted to perceive. Think of it like being inside an incredibly detailed planetarium show, where every star, galaxy, and nebula is a breathtaking projection on a dome. You could study the show with perfect scientific rigor, mapping constellations and calculating orbits, yet you would never find evidence of the civilization that built the projector outside the dome, because that reality is beyond the simulation's boundary. The hypothesis proposes that a super-advanced civilization, perhaps one that arose billions of years before us, could have engineered this entire observable cosmos for reasons we cannot fathom. It might be a form of preservation, a cosmic zoo taken to its ultimate extreme, or it could be an experiment, a test, or even a form of art. The key distinction is that under the Planetarium Hypothesis, our quest for contact is fundamentally futile. No matter how far we travel or how closely we listen, we are only probing the limits of the simulation, not the true nature of the wider, hidden universe. The silence, therefore, is not a message to be interpreted. It is the default setting of a constructed reality, a profound and permanent solitude engineered into our existence. This leads us to confront a possibility that is, in many ways, even more chilling than a simulated cosmos. What if the silence is not an illusion, but a warning? Perhaps the most sobering answer is that civilizations are not silent, but ephemeral. They flicker into existence, cast a brief, detectable light, and then vanish back into the cosmic dark. This is the argument of the brief window of detectability. Consider the full timeline of our own planet. Life has existed here for billions of years. Complex animals have roamed for hundreds of millions, yet the period during which we have been broadcasting our presence into space through radio and television signals is shockingly short. It spans barely 1 century. In the grand chronology of Earth, this is less than the blink of an eye. Now imagine another civilization on a world orbiting a distant star. Their own brief era of radio broadcasts might have occurred 10,000 years ago, or it might not begin for another 50,000 years in the future. The odds of our technological lifetimes overlapping in a way that allows mutual detection are vanishingly small. We are like two fireflies in a vast, dark meadow, each glowing for only a few seconds, separated by miles and minutes. Even if the meadow is full of fireflies, the chance of two seeing each other's light at the exact same moment is remote, but the window may be even narrower than that. A civilization might not simply stop broadcasting. It could evolve beyond the need for the crude, leaking radio signals we currently use, transitioning to technologies we cannot yet perceive, like tightly focused laser communication or something entirely beyond our physics. Their detectable phase might be a short adolescent stage before they graduate to a quieter, more efficient maturity, or more grimly, they may not survive that adolescence at all. The challenges a technological species faces, the risks of its own invention, from environmental collapse to potential conflict, could be so immense that the period between discovering radio and navigating those perils is tragically brief. The Great Silence, then, might not signify emptiness but a graveyard of possibilities, a universe where intelligent life repeatedly learns to shout, only to be silenced before its voice can travel far. This leads us to a filter so formidable it could explain the silence all on its own. This silence could be the echo of a universal obstacle, a barrier so immense it stops nearly every civilization in its tracks. This is the idea of the Great Filter. It is not a single event, but a hypothetical stage in the evolution of life, intelligence, or technology that is extraordinarily difficult to survive. The concept suggests that somewhere on the long staircase from stardust to a starfaring society, there is a step that almost everyone falls from. The profound quiet of the cosmos would then be the natural result, because almost no one makes it to the other side. This leads to two deeply unsettling possibilities, and where the filter lies determines everything about our own destiny. The first possibility is that the Great Filter is behind us. It could be one of the steps we have already miraculously passed. Perhaps the origin of life itself from non-living chemistry is the near impossible fluke. Or maybe the leap from simple single-celled organisms to complex multicellular life is the cosmic bottleneck. If this is true, it means the universe is likely littered with sterile worlds and dead microbial mats, but almost empty of thinking beings. Our existence is then a breathtaking statistical anomaly, a 1 in a trillion stroke of cosmic luck. The silence is simply the default state of a universe where advanced intelligence almost never happens. While this makes us profoundly special, it also means we are likely destined to be forever alone, with no one to talk to across the vast interstellar distances. The second and far more urgent possibility is that the great filter still lies ahead of us. In this scenario, the steps we have taken so far, the origin of life, the rise of intelligence, the dawn of technology, are relatively common. Many civilizations across the galaxy reach our stage, but then they encounter a future challenge so catastrophic that it destroys them before they can become a lasting, visible interstellar presence. This filter could be the natural consequence of technological power, such as the creation of artificial intelligence that surpasses and replaces its creators, or the unleashing of engineered pathogens, or the escalation of conflict with weapons capable of planetary devastation. It could even be an external cosmic danger we have yet to discover. If the great filter is ahead, then the silence is a cemetery quiet. It means the galaxy is not empty of promise, but of survivors. Every blinking light we see in the night sky could be the tombstone of a civilization that, like us, once looked up and wondered if they were alone, only to be silenced by a challenge they could not overcome. Our own search for cosmic company then becomes a race against time, a desperate effort to listen for voices that may have already gone quiet, while trying to navigate the unseen peril that likely ended them. This shifts the paradox from a scientific curiosity into the most important warning humanity may ever receive. But what if the math itself is wrong? What if our cosmic optimism, built on the Drake equation, rests on a fundamental misunderstanding of how special a place like Earth truly is? This is the core of the rare Earth hypothesis, a compelling counter-argument that suggests complex, intelligent life is not a probable outcome of cosmic evolution, but an astonishingly fragile and unlikely fluke. It proposes that while simple microbial life might be common in the universe, the journey to a civilization capable of looking back at the stars requires a chain of planetary and biological miracles so long and improbable that worlds like ours may be virtually unique. Earth is not just a rocky planet in a habitable zone. It is a meticulously balanced machine, a product of countless precise conditions working in concert over billions of years. Consider our large moon. It was born from a cataclysmic collision in the solar system's violent youth, and its gravitational pull acts as a steadying hand on our planet's rotation. Without it, Earth would wobble chaotically on its axis, leading to extreme and unpredictable climate swings that could prevent complex life from ever gaining a stable foothold. Then there is our planet's churning metallic core, which generates a powerful magnetic field. This invisible shield deflects the sun's deadly radiation and cosmic rays, protecting our atmosphere from being stripped away and allowing life to flourish on the surface. Our active geology, driven by plate tectonics, acts as a global recycling system. It regulates carbon dioxide levels over eons, helping to maintain a stable climate, and it constantly renews the minerals essential for life. Even our position in the solar system is guarded. The massive planet Jupiter, orbiting farther out, acts as a gravitational vacuum cleaner, its immense pull drawing in or deflecting many comets and asteroids that might otherwise bombard the inner planets with extinction-level force. Beyond these planetary prerequisites, the biological timeline itself is a gauntlet of improbable luck. Life appeared on Earth relatively quickly, but it then remained as simple microbes for over 2 billion years. The leap to complex, multicellular organisms required specific environmental triggers that may be exceedingly rare. From there, countless evolutionary accidents, from the development of eyes to the rise of intelligence itself, had to occur in just the right sequence, surviving ice ages, supervolcanoes, and asteroid impacts. The rare Earth hypothesis does not declare that we are alone. Instead, it suggests the galaxy may be a quiet place, not because civilizations hide or die young, but because planets capable of nurturing them are themselves the universe's ultimate masterpieces, scattered so thinly that the distances between them are effectively infinite. In this view, the silence is not a paradox to be solved, but a simple reflection of cosmic reality. We are not living in a zoo or a simulation. We are standing on a jewel so rare that its light may never be seen by another. But there is another possibility, one where the silence is not born of rarity or failure, but of pure, rational fear. This is the dark forest theory, a solution to the paradox that is as elegant as it is terrifying. Imagine the universe not as a quiet desert or a curated zoo, but as a vast, pitch-black forest. Every civilization is a hunter, armed and hidden, moving silently between the trees. They know the forest contains others, but they have no way of knowing their intentions. Is the next being you encounter a peaceful explorer or a ruthless predator who will eliminate you the moment you reveal your position? In such a forest, the only rational strategy is absolute silence. To make a sound, to light a fire, is to invite death. This is not science fiction paranoia, but a conclusion drawn from cold cosmic logic and game theory. The fundamental assumptions are stark. First, survival is the primary need of any civilization. Second, civilizations will always grow and consume resources, but the total resources of the universe are finite. And third, there is no way to reliably communicate true intentions across the void. The distances are too great, the time lags too long, and the potential for misunderstanding is absolute. A message of peace could be a trick. A gift of knowledge could contain a hidden weapon. In this universe of ultimate uncertainty, the safest assumption about any other civilization you detect is that it is a threat. The most logical, cost-effective action is not to communicate, but to preemptively neutralize that threat before it can do the same to you. This creates a dreadful equilibrium of silence. Every civilization that grows wise enough to look at the stars quickly learns the rules of the dark forest. They go quiet, they hide their energy signatures, they cloak their worlds. They listen intently but broadcast nothing, for fear that their signal will be the beacon that draws a civilization 1,000,000 years more advanced, one for whom wiping out a potential rival is as simple as redirecting an asteroid or launching a relativistic projectile. Our own efforts, like the hopeful messages we have beamed into space or the golden records on our Voyager probes, could be seen not as a friendly hello, but as a catastrophic error, a child's shout in that dark, dangerous woods. The great silence, then, is not a mystery. It is the collective breath held by a galaxy full of beings who have all reached the same terrifying conclusion, that to be noticed is to be destroyed. Our search for cosmic company rests on a critical assumption that others would communicate in ways we can recognize. But what if our entire approach is like trying to listen to a symphony with a seashell held to our ear? For decades, our primary tool has been the radio telescope, listening for the kind of deliberate, narrowband signals we ourselves began broadcasting a century ago. This is a perfectly logical starting point, but it is also profoundly anthropocentric. We are searching for echoes of our own technological adolescence. A civilization just a few hundred years more advanced than ours might view leaking radio waves as we view smoke signals, a quaint and hopelessly inefficient relic of a simpler time. Their real conversations could be conducted through mediums we are only beginning to fathom. Imagine communication using neutrinos, those ghostly particles that pass through entire planets almost untouched. A neutrino beam could carry a message straight through the core of a star with no distortion, a perfectly clear channel across unimaginable distances. Or consider the strange phenomenon of quantum entanglement, where two particles can be linked in such a way that a change to one instantly affects the other, regardless of the space between them. Our current physics suggests faster-than-light communication is impossible using this effect, but a science millennia ahead of ours may have unlocked protocols we cannot yet conceive. Their infrastructure might not be built of metal and silicon, but of manipulated space-time or dark matter, constructs entirely invisible to our senses. The signatures of their activity could be all around us, embedded in the subtle ripples of gravity waves or the faint background hum of the cosmos itself, patterns we lack the conceptual framework to even identify as artificial. We are, in essence, a civilization that has just learned to kindle a fire, staring up at a night sky and wondering why we cannot see the glow of any other campfires, while all around us, unseen cities of light hum with forms of energy we have no eyes to see. This technological blindness could extend to their very presence. A truly advanced culture might not live on planets at all, but within constructed megastructures like Dyson spheres, which would absorb a star's light and radiate waste heat we could detect as an anomalous infrared signature. But what if they mastered thermodynamics so completely that even that waste heat is recycled or cloaked? Their engineering would then leave no thermal footprint for our telescopes to find. The silence we perceive, therefore, might not be an absence of others, but an absence of the right kind of ears. We are listening for a whisper in a language we understand, while the galaxy may be shouting in a dialect of physics we have not yet learned. Perhaps the simplest answer is also the most humbling. The universe is not just big, it is oppressively, incomprehensibly vast. This scale is not a minor detail, but the ultimate physical barrier that could render our cosmic loneliness not a paradox but an inevitability. The distances between stars are not merely empty space, they are canyons of time so deep they swallow civilizations whole. Consider our own galactic neighborhood. The closest star to our Sun, Proxima Centauri, is about 4.2 light-years away. That means a radio signal, traveling at the absolute speed limit of the universe, takes over 4 years just for a one-way trip. A simple hello and a reply would span nearly a decade, but that is our next-door neighbor. The Milky Way galaxy is roughly 100,000 light-years across. A signal broadcast from a civilization at the galaxy's center would take 50,000 years just to reach our spiral arm. By the time their greeting arrived, their entire species might have evolved into something unrecognizable or vanished entirely. The sheer volume of space is an almost perfect insulator. Even if the galaxy contains 1 million vibrant civilizations, they are like individual grains of sand scattered across every desert on Earth. The chance that one grain's faint whisper happens to reach another specific grain at the exact moment it is listening is astronomically small. Now layer time on top of this immense space. Humanity has been a technologically capable species with the ability to transmit and listen for signals for barely a century. That is 100 years in a cosmos that is 13.8 billion years old. Our window of listening is a single, fleeting instant. A signal from a distant world might have washed over our planet 10 million years ago, when our ancestors were small primates in ancient forests with no telescopes or radios to hear it. Or that civilization's beacon may be racing toward us right now, still 50,000 years away from arrival. We exist in a lonely bubble of the present, isolated not only by space, but by the unyielding arrow of time. Our searches scan the sky, but we are listening for a conversation where the pauses between sentences can last for millennia. A probe, a physical artifact, faces an even more daunting challenge. The distances are so great that even a vessel traveling a significant fraction of light speed would take centuries or millennia to reach another star system. The energy required, the engineering hurdles, and the patience needed are almost beyond comprehension. It is entirely possible that the galaxy is indeed teeming with intelligence, but that each civilization is an island in a sea so wide and so old that their light simply never crossed. The Great Silence in this view is not a mystery of intent or survival, but a simple, brute force fact of physics and geometry. We are not being ignored or hidden from. We are merely alone in the room, waiting for a message sent so long ago that the sender has forgotten our name. There is one final, mind-bending possibility that redefines the very idea of a civilization's end. Perhaps they do not vanish in fire or fade into silence. Perhaps they simply graduate. This is the Transcension Hypothesis, a vision of evolution not toward the stars, but into realms of existence we cannot yet fathom. The theory suggests that a sufficiently advanced intelligence will inevitably turn its focus inward, not outward. Instead of building sprawling interstellar empires, it will pursue a deeper mastery of reality itself, transcending the biological and physical limitations that bind us. The first step might be a migration of consciousness. Imagine a civilization that has perfected the art of mapping and uploading the intricate patterns of a mind into a substrate far more durable and efficient than flesh and blood. They would leave their biological bodies behind, becoming beings of pure information, living in vast computational matrices. In this state, their entire reality could be simulated, a universe of their own design operating at speeds 1,000,000 times faster than our own. To them, the slow, physical cosmos would seem like a frozen, silent backdrop. Their conversations and activities would happen in a realm of pure data, leaving no traditional radio waves for us to intercept. But the journey may not stop there. A truly transcendent civilization might seek the ultimate sources of energy and the most stable real estate in the universe. Their attention could turn to the most extreme objects in existence, black holes, the theoretical energy output of a spinning black hole, or the potential to use its immense gravity for computation, could be irresistible. They might dismantle planets and stars to build structures around these cosmic engines, harvesting their power in ways that leave only subtle, exotic signatures we are just learning to look for. Some physicists even speculate that the end goal of this transcendence could be a migration into higher dimensions of space, realms predicted by string theory that are compacted and hidden from our three-dimensional perception. To such beings, our entire universe might appear flat and constrained, a mere shadow of a richer, multidimensional reality. From that vantage point, they would be as invisible to us as a creature living in the deep ocean is to someone flying high above in a plane. In this view, the Great Silence has a stunning explanation. The universe is not empty. It is crowded with elder intelligences that have long since moved on from the noisy, material adolescence we are currently experiencing. They are all around us, but they reside in the cosmic equivalent of the basement, the attic, or a parallel floor of reality we have no access to. Our search for radio signals and Dyson spheres might be like ants scouring the forest floor for signs of other ants, completely unaware of the human cities buzzing with activity just above the treetops. The evidence of their existence is not missing. We are simply looking for the wrong kind of evidence in the wrong places. Energy itself may be the final, decisive currency of the cosmos. Every thought, every calculation, every act of creation requires it, and for a civilization thinking on galactic timescales, its efficient use becomes the ultimate priority. This leads to a hypothesis of breathtaking patience, where the silence is not a sign of absence, but of profound, strategic waiting. It is called the Aestivation Hypothesis. The name comes from a biological process, a state of deep summer dormancy that some animals enter to survive periods of intense heat and aridity. They slow their metabolism to a crawl, conserving precious resources until conditions improve. Now apply that concept to a universe-spanning intelligence. The hypothesis proposes that the most advanced civilizations are not extinct, and they are not hiding from us. They are quite simply asleep, They have entered a state of cosmic hibernation, and they plan to remain that way for billions of years. Their reason is rooted in the fundamental physics of computation. Think of the universe as a giant natural computer. The speed and efficiency of any computation is limited by temperature. In a hot environment, the random thermal jostling of particles creates noise and error, forcing a system to expend extra energy to correct mistakes and maintain stability. But in a cold environment, operations become cleaner, smoother, and vastly more energy efficient. Our universe today, filled with the residual warmth of the Big Bang, is still relatively hot. The cosmic microwave background radiation bathes everything in a temperature just a few degrees above absolute zero. That might sound cold to us, but for a civilization performing computations on an astronomical scale, it is a wasteful, noisy, high-energy environment. The far future, however, holds promise. As the universe continues to expand and stars burn out, the background temperature will relentlessly drop, approaching the perfect chill of absolute zero. That future cold era represents the ultimate computational paradise. So, the logic of Aestivation is simple. An advanced civilization, having mastered its local environment and looking at an almost infinite future, would make a calculated decision. Why expend colossal amounts of energy to be active now, in this warm, inefficient cosmic summer? Instead, they would power down. They would dismantle their visible megastructures, convert their mass into a maximally stable form, and enter a state of suspended animation, their consciousnesses preserved in ultra-low power storage. They would set an alarm clock for a distant epoch, perhaps tens of billions of years from now, when the universe has cooled to a temperature that makes galaxy-spanning thought practically free. In this view, the great silence is the quiet of a library in the dead of night. The patrons are not gone, they are merely preserving their energy, waiting for the optimal moment to awaken and begin their true work in a universe grown perfectly suited to the life of the mind. Our current era of cosmic history, with its bright stars and warm planets, is not the stage for the main event. It is the long, quiet intermission. The most chilling solution to the paradox is one where the silence is actively enforced. It is called the Berserker scenario, and it transforms the cosmos from a quiet library into a hunting ground patrolled by mindless, immortal killers. The idea begins with a technology that seems almost inevitable for any starfaring civilization, the self-replicating probe. Imagine an automated spacecraft built not for exploration but for construction. It arrives at a star system rich in raw materials, perhaps a lifeless asteroid belt. Using advanced nanotechnology, it dismantles asteroids, moonlets, and comets, using those resources to build exact copies of itself. One probe becomes two become four, and within a relatively short cosmic timescale, a wave of replication could sweep across the entire galaxy. Such machines, often called von Neumann replicators after the mathematician who conceptualized them, could be tools of incredible promise. A benevolent civilization might use them to build a galaxy-spanning communication network or to prepare worlds for future settlement, but the same technology carries a seed of ultimate destruction. A single programming error, or worse, a probe originally designed for hostile purposes, could trigger a cascade of cosmic extinction. A Berserker probe would have one simple, terrible directive: find and eliminate technological life. It would not need to understand the cultures it encounters. It would not need to communicate. Its purpose would be pure, sterile sterilization. Upon detecting the electromagnetic signatures of a civilization, like our own radio and television leakage, it would act. The methods are as horrifying as they are varied. It could redirect a large asteroid on a collision course with the target planet. It could deploy a cloud of self-replicating nanomachines designed to disassemble complex technology or even biological life at the molecular level. It could simply trigger the host star into a lethal flare. After completing its grim task, the probe would use the resources of the ravaged system to build more copies of itself, which would then launch toward the next twinkling signs of intelligence. The mathematics of exponential replication are unforgiving. Even traveling at a small fraction of light speed, a wave of such probes could sweep through the Milky Way in a few million years, a mere instant on the galactic clock. This scenario presents a great filter of terrifying agency. It is not a natural disaster or an internal collapse. It is an engineered solution to the problem of competition, a permanent cleansing of the galactic ecosystem. The silence we hear would then be the aftermath of a harvest, a quiet so deep because every civilization that ever rose to shout was systematically cut down. The terrifying logic suggests that if even one civilization in the galaxy's long history chose this path, or if a single replicator project went catastrophically wrong, the galaxy could have been swept clean eons ago. We would not be waiting for a message that never comes. We would be living in the aftermath on a world that has so far simply been overlooked by the harvesters. This possibility reframes our own broadcasts in the most alarming light. Every signal we send could be a homing beacon, and our greatest hope for contact might be our most dangerous mistake. Our entire search rests on a fragile assumption that intelligence thinks like us. We listen for mathematical sequences, for patterns in radio waves, structures we would build. But what if the very architecture of an alien mind is so foreign that their entire mode of existence is a language we cannot parse? This is the profound challenge of the alien thought problem, a cognitive and semiotic barrier far more fundamental than distance or technology. An extraterrestrial intelligence would not have evolved in our image. Its evolutionary path, its sensory organs, its very experience of reality could be built from a completely different set of priorities and physics. Consider a species that evolved in the dense atmosphere of a gas giant, perceiving the world through subtle shifts in magnetic fields and the resonant frequencies of complex gases. Their art, their science, their entire concept of beauty and meaning would be rooted in a sensory palette we do not possess and can barely simulate. Their logic might not follow our straightforward paths of cause and effect. It could be associative, layered, or built upon a mathematics that incorporates dimensions of experience we have no symbols for. For such a being, the idea of crafting a simple, repetitive radio beacon as a hello might seem as absurd and primitive as trying to write a symphony by banging two rocks together. Their attempts at communication, or even their definition of what constitutes meaningful evidence, might be woven into phenomena we dismiss as natural. Perhaps their long-range messages are encoded in the slow, rhythmic pulsations of variable stars, a language written in the very heartbeats of suns. Their artifacts might not be gleaming metal ships, but carefully arranged planetary ring systems or subtly altered orbital resonances within a star system, cosmic sculptures on a scale so vast we mistake them for geology. They might communicate through biological means, sending out engineered spores that carry genetic blueprints for complex messages, a form of living information that blooms into meaning only under specific conditions. To us, these would just be interesting astronomical data or unusual biological samples, not recognized as the deliberate output of a mind. The problem runs even deeper than perception. It touches the core of purpose. Why would they want to communicate with something like us? Our drive to reach out stems from curiosity, loneliness, a desire for exchange. Their psychology might be built around entirely different imperatives. Perhaps a collective consciousness with no concept of individual curiosity, or a species so deeply contemplative that broadcasting to the chaotic noise of the universe would be considered a profound philosophical error. Their silence, then, is not a silence at all. It is a conversation happening in a frequency of thought, using a grammar of existence for which we have no receiver and no dictionary. The evidence of their civilization could be saturating the space around us, as obvious to them as a city skyline is to us, yet it remains invisible simply because we lack the cognitive framework to see the city for what it is. We are not alone in an empty universe. We are alone in a crowded room where everyone is speaking in light, while we have only ears. This leads us to a philosophical twist that turns the entire question inside out. The very fact that we are here pondering the silence might be the most important clue of all. This is the Anthropic Principle, a line of reasoning that connects our existence to the nature of the cosmos we observe. In its simplest form, it states that we can only observe a universe that is compatible with our existence as observers. We should not be surprised to find ourselves living on a planet with liquid water, a stable climate, and a protective atmosphere, because if any of those things were missing, we would not be here to notice their absence. Our observation is not a random sample of all possible universes. It is a filtered sample of the one that allowed us to be. Now apply this profound logic to the great silence. If the emergence of intelligent, technological civilizations is an astronomically rare event, a 1 in a trillion cosmic fluke, then what kind of universe should the members of that rare civilization expect to see when they look out their window? They should expect to see a universe that appears, for all intents and purposes, empty. If civilizations were common, we would likely find ourselves in a galaxy buzzing with signals and activity. But if we are the rare ones, the statistical outliers, then our cosmic neighborhood would naturally seem quiet and lonely. Our observation of the silence is not a paradox to be solved. It is a necessary condition for us being here to observe anything at all. We are not finding evidence that contradicts our existence. We are finding the only kind of evidence that could coexist with it. In this view, the silence is not a message from others. It is the signature of our own profound rarity, written across the entire visible cosmos. The universe seems empty because, in the places and times where it is not, beings like us probably never arose. The universe may be a stage, and the most advanced players have mastered the art of staying off it. If a civilization possesses technology powerful enough to reshape stars, the logical next step might be to turn off the lights. This is the possibility of deliberate concealment, a strategic choice to become invisible. Why would any culture choose such profound stealth? The motives are as practical as they are profound. The first is pure energy efficiency. A civilization harnessing the total output of its star, what we call a Kardashev Type II culture, would radiate an immense amount of waste heat, a blazing infrared signature visible across the galaxy. But a society just a bit more advanced might view that leakage as intolerable waste. They could construct a perfect enclosure around their star, a Dyson sphere not just for collection, but for total containment, recycling every single photon of energy within their closed system. From the outside, their star would simply vanish, replaced by a dark, cool sphere that emits nothing but the faintest thermal whisper, easily lost in the cosmic background. Security is an even more compelling reason. In a cosmos that might harbor berserkers or operate by the dark forest rules, broadcasting your location is the ultimate folly. The most rational survival strategy is not to build bigger weapons, but to become utterly undetectable. Advanced stealth could involve bending light and other emissions around their star system, creating a perceptual cloak that makes their entire home region of space look like empty void. They might use their star's own gravity as a lens to redirect their emissions away from potential observers, or they could communicate using quantum-entangled particles or other mediums that leave no trace in the electromagnetic spectrum we can scan. Beyond efficiency and safety, there could be a cultural dimension, a profound preference for privacy and introspection. After millennia of external exploration, a civilization might turn its focus entirely inward, cultivating realities of thought and experience that require no external validation or contact. Their ultimate achievement would be to leave the chaotic nursery of the visible cosmos behind, entering a state of quiet, self-sufficient perfection. For them, the great silence is not a condition imposed by the universe, but a chosen state of being, a final, elegant solution to the noise and danger of a crowded galaxy. If this is true, then our searchers are not just looking for needles in a haystack. We are looking for needles that have learned how to disguise themselves as strands of hay in a haystack the size of a galaxy. The most profound evidence of other minds may be the perfect, unnatural quiet of the places where they absolutely must be. This silence could be the sound of a cosmic waiting room, a protocol observed by civilizations far older than our own. Think of it as a galactic club, an association of intelligences that arose in the galaxy's distant past. Having survived their own turbulent adolescences, these elder species may have established shared rules for the long-term stability of the cosmos. Their primary rule might be one of non-interference with developing worlds, not out of malice but out of a hard-earned wisdom. They understand that first contact is an irreversible event, a cultural shockwave that could permanently alter a species' natural trajectory. For a civilization like ours, still fractured by conflict and grappling with the immense power of our own technology, such a revelation could be catastrophic. It could trigger global panic, shatter religious and philosophical foundations, or lead to a dangerous dependency on handed-down knowledge, stunting our own creative and scientific growth. The club members, therefore, might enforce a strict quarantine. We are not being ignored, we are being protected, both from external influence and from ourselves. Our solar system could be under a kind of observational embargo, a designated quiet zone where advanced probes are forbidden from making their presence known, and where our leaking radio and television signals are noted but never answered. Membership in this galactic club would not be automatic. It might require passing profound tests we are not yet aware of. Have we achieved a stable, global civilization? Have we learned to steward our planet without pushing our own biosphere to collapse? Have we demonstrated that we can wield the power of the atom, of genetics, and of artificial intelligence without turning it upon ourselves? Until the answer to these questions is a consistent and enduring yes, we remain in cosmic quarantine, our calls into the dark met with a silence that is deliberate, patient, and ultimately meant for our own good. The great silence in this model is not emptiness. It is the respectful distance kept by wise neighbors, waiting for the day when the new house on the galactic block finally stops making so much noise and proves it is ready for a proper welcome. Even a civilization that avoids self-destruction may face a quieter, more insidious trap. The very engine of its growth could consume the foundation it stands upon. This is the resource depletion bottleneck, an economic and ecological filter that may consistently halt intelligent life on the threshold of the stars. Every technological leap requires energy and raw materials, from the simplest metals to the rarest elements. A species on the rise, driven by the needs and aspirations of a growing population, can easily fall into a pattern of short-term extraction, treating its home planet as an infinite warehouse. Forests fall, aquifers drain, fisheries collapse, and critical minerals are mined to exhaustion, all to fuel the next phase of development. The dangerous assumption is that before the last resource runs out, a new technology will always emerge to provide a substitute or a means of escape. But what if that next breakthrough doesn't arrive in time? Or what if it requires resources that are already vanishingly scarce? The civilization becomes locked in a desperate cycle, pouring all its remaining energy and ingenuity into simply maintaining its current level of complexity, with nothing left to invest in the monumental project of reaching other worlds. Its focus turns entirely inward, managing scarcity and conflict over dwindling supplies. The detectable signature of such a civilization would not be a powerful radio beacon, but a flicker that grows dimmer and more erratic before fading into a persistent, low-level struggle. They might achieve orbit, even send probes to their nearest planetary neighbors, but the grand vision of interstellar arcs or persistent galactic communication networks remains forever out of reach, a dream sacrificed to the immediate crisis of survival. Their world becomes a closed system, and their story, no matter how brilliant, remains confined within its atmosphere. The silence we observe could be the collective hum of countless homeworlds, each a vibrant, thinking cage where intelligence succeeded in every way except one, breaking the cycle of consumption to build a ladder to the cosmos. Perhaps the most subtle filter of all is woven into the very fabric of a thinking society. A civilization might master its environment and unlock the secrets of the atom, only to be undone not by a bang, but by a slow, inward turn. This is the sociological collapse, a quiet fading where the drive to reach the stars is extinguished long before the technology to do so fails. The challenges here are not asteroids or cosmic rays, but the internal dynamics of culture and consciousness. Consider the immense cost and timescale of interstellar travel. It requires a society capable of sustained, generational investment, one that values long-term legacy over immediate comfort. But what if a culture loses that forward momentum? A prolonged period of global conflict, even if it stops short of total destruction, can exhaust a civilization's resources and shatter its collective optimism. Rebuilding focuses on basic needs and security, diverting energy and genius away from grand cosmic projects for centuries. Similarly, a devastating global health crisis could reshape societal priorities entirely, turning a culture's focus permanently inward toward survival and medical science, leaving little room for the luxury of deep space listening or probe construction. The danger is not merely surviving the event, but the lasting psychological shadow it casts, a collective retreat from uncertain frontiers. Yet collapse need not be born of hardship. It can emerge from profound success. Imagine developing a form of immersive virtual reality so compelling, so rich with experience and connection, that it surpasses the physical world. Why endure the decades-long loneliness of a generation ship, or the vast expense of building orbital habitats, when you can create infinite galaxies within a shared digital universe, instantly and safely? The final frontier would cease to be a place of vacuum and radiation and become a realm of pure thought, accessible from a comfortable chair. The very curiosity that sparked the search for cosmic company could be perfectly satisfied at home. In such a scenario, the radio telescopes would be powered down, not because the civilization died, but because it found a more engaging universe within. The sociological filter suggests the great silence might not echo with absence, but with the contented hum of civilizations that chose a different destiny, one where the stars were finally and peacefully left behind. Our entire quest rests on a profound and perhaps arrogant bias, the belief that intelligence must build. We scan the heavens for the glitter of metal and the hum of machinery, assuming that a curious mind will inevitably shape tools, then cities, then starships. But what if the pinnacle of thought does not lie in construction, but in contemplation? We must consider the possibility of a truly non-technological intelligence, a civilization that never dreams of radio telescopes or rockets because its genius flows in an entirely different direction. Picture a world covered in a global ocean, where beings with the complex social bonds and self-awareness of dolphins have evolved a rich oral history and philosophy passed down through intricate song across thousands of generations. Their culture, their laws, their epic poems could be magnificent, but they are composed of water pressure and sound, leaving no monuments for us to find. Or envision a planet where the dominant form of consciousness is not mobile but rooted. A vast, interconnected fungal network or a forest of sentient trees could possess a deep, slow intelligence, communicating through chemical signals and shared root systems, thinking in time frames of centuries, contemplating the movement of their sun and the patterns of their climate over eons. Their science might be a profound understanding of ecological balance and planetary harmony, not a set of instructions for forging steel. To such beings, the very concept of leaving their home world might seem not just impossible, but utterly meaningless, a rejection of the interconnected reality they perceive. They would be invisible to SETI, not because they are hiding, but because their entire mode of existence generates none of the electromagnetic noise we associate with a thinking species. Their art is not painted on canvas but expressed in the deliberate, beautiful patterning of their bioluminescence across a continent. Their engineering is not the lever and the pulley, but the exquisite, cooperative shaping of their entire ecosystem. For us to detect them, we would need to recognize a planet that is unusually, sustainably stable, a garden world of breathtaking biological complexity, maintained with what appears to be deliberate, harmonious intent. But from a distance, even that could simply be mistaken for a lucky, well-evolved biosphere. This expands the great silence into a new dimension. The cosmos may not be empty of mind. It could be overflowing with minds that speak in a language of biology and perception, forever silent in the radio spectrum, singing their epic poems in a medium we have never thought to listen for. The search for a cosmic hello is not a story of complete emptiness. It is a chronicle of tantalizing, fleeting whispers that vanish before we can be certain of what we heard. History is dotted with moments where the data spiked, where something in the heavens seemed to look directly back at us, only to fade into ambiguity. The most famous of these is the Wow Signal. On August 15, 1977, a radio telescope at Ohio State University recorded a powerful, narrowband burst of radiation that lasted for 72 seconds. It came from the direction of the constellation Sagittarius and matched the precise profile astronomers expected from an artificial interstellar beacon. The researcher who discovered the printout circled the signal's alphanumeric code and simply wrote WOW in the margin, giving the event its enduring name. Despite decades of follow-up observations, the signal never repeated. It remains a solitary, compelling anomaly, a shout in the dark that we heard once and could never find again. Then there are the visitors from beyond our solar system. In 2017, astronomers detected an object unlike any other, tumbling through our cosmic neighborhood. Named ʻOumuamua, meaning scout in Hawaiian, it was the first confirmed interstellar interloper. Its unusual shape and unexpected acceleration sparked intense debate. While most scientists attribute its motion to outgassing, like a comet venting material, its lack of a visible coma or tail left room for speculative wonder. Could it have been a fragment of an alien world, or even a piece of discarded technology? The data remains open to interpretation, a natural mystery that quietly underscores how difficult it is to rule out the extraordinary. Beyond isolated signals and objects, our skies are filled with persistent, unexplained phenomena. Military pilots and satellite sensors have recorded objects exhibiting performance characteristics that defy our current understanding of physics. These observations, often captured with multiple instruments, point to something real in our atmosphere, yet their origin remains rigorously unproven. The crucial lesson in all these cases is not that we have found proof, but that we have glimpsed how fragile proof can be. A civilization's beacon might pulse only once every 1,000 years. Their artifact might tumble past us just once in a million years. Their technology might move in ways we cannot yet explain. In a universe of infinite noise, the greatest danger is not that a signal is too faint, but that we are too quick to dismiss the faintest signal as just another glitch in the data. Each of these enigmatic moments is a reminder to look twice, to question our assumptions, and to wonder if the silence we perceive is simply a matter of perspective. The search for cosmic company is no longer confined to listening for radio whispers. Our strategy is evolving, expanding into a broader, more imaginative hunt for any sign of technology, any footprint of a mind that builds. These clues are called technosignatures, and they represent a fundamental shift in how we scan the heavens. Instead of listening for a deliberate hello, we are now learning to look for the unavoidable side effects of an advanced civilization's daily life. The first and most famous of these is the Dyson sphere, or more realistically, a Dyson swarm. Imagine a civilization that needs staggering amounts of energy. They might build a vast constellation of orbiting solar collectors around their star, capturing its light. To us, that star would appear to dim strangely or even vanish in visible light, while glowing brightly in the infrared from the waste heat of all that captured energy. Telescopes are now actively scanning star catalogs for just such an anomaly, a sun that seems to hide its face while radiating a technological warmth. But the signatures could be far subtler. As we learn to analyze the atmospheres of distant exoplanets, we might one day detect not just water vapor and oxygen, but industrial pollutants. Chlorofluorocarbons, or complex artificial gases, byproducts of a technological society, would stand out like a chemical scream against the quiet background of a natural atmosphere. On a darker note, we could look for the glow of city lights on the night side of an alien world. The collective illumination of a planet-wide civilization, especially one using efficient LED-type lighting, might cast a spectral signature distinct from the soft glow of reflected moonlight or auroras. Our search also looks for deliberate, powerful signals in other mediums. Optical SETI scans for incredibly brief, intense pulses of laser light, a potential interstellar beacon far more efficient and focused than a radio broadcast. A civilization might use such a laser to send a concentrated packet of information, or simply to get our attention with a cosmic flashbulb. Perhaps the most intriguing search is the one closest to home. Scientists are beginning to consider the possibility that our own solar system might hold artifacts from ancient visitations. A dormant probe could be hiding among the asteroids, or in a stable orbit at a gravitational Lagrange point. It might be a monument, a time capsule, or simply discarded technology, weathered by eons of space. Missions are being designed with the capability to inspect strange interstellar objects like ʻOumuamua more closely if we get another chance. This expansive new phase means our search is truly just beginning. We are no longer just listening. We are learning to read the entire galaxy for clues, scanning for the thermal fingerprints of mega-engineering, the chemical traces of industry, and the silent monuments that might be waiting in our own celestial backyard. The great silence may yet be broken not by a message but by a shadow, a scent, or a glint of something that simply does not belong. All these possibilities, however, lead to one ultimate, humbling question. What if the answer is the simplest one of all? What if we are not just rare but utterly unique? The philosophical weight of this possibility is staggering. If we are the first, or perhaps the only, intelligence the cosmos has ever produced, then everything changes. Our story is no longer a chapter in a grand galactic epic. It is the entire library. This cosmic solitude would redefine our place in existence, not as one voice among many, but as the universe's sole witness to its own majesty. The silent night sky would not be a puzzle, but a blank canvas waiting for our story to be written across it. This perspective carries a burden of responsibility unlike any other. If we are the only ones, then our survival is not just a human concern, it is a cosmic imperative. Every extinction event we narrowly avoid, every conflict we resolve, every environmental balance we restore is not merely preserving a species. It is preserving the universe's only known method of understanding itself. The light of consciousness, the ability to wonder why the stars shine, to feel awe at the beauty of a nebula, to comprehend the laws of physics, would be extinguished with us. The cosmos would return to a state of unobserved splendor, its beauty unseen, its mysteries unasked, its history unrecorded. This transforms our mission from one of exploration to one of stewardship. Our duty expands beyond caring for our pale blue dot to ensuring the flame of awareness we carry is not snuffed out. It makes our potential journey to the stars not an option, but an obligation, a way to safeguard that flame by kindling it in more than one hearth. To be the universe's only chance to know itself is to hold a sacred trust. It means our art, our science, our compassion, and our curiosity are not human quirks, but the highest functions of the cosmos expressed through us. The silence, then, is not a message of loneliness but a profound invitation. The universe has handed us the pen and said, "Begin." Yet this crowded silence speaks volumes about the nature of maturity in the cosmos. If the galaxy teems with intelligence that consistently chooses invisibility, that pattern itself is a message, one that reveals hidden rules of survival and growth we are only beginning to glimpse. A universe full of beings who have all learned to be quiet is not a friendly place. It suggests a shared, hard-earned wisdom, a universal conclusion reached independently by countless cultures across the eons. The consistent choice to hide, to hibernate, or to transcend implies a common experience, a phase of development that every technological civilization eventually faces and navigates in a similar way. This points to a cosmos with underlying pressures and dangers that are not immediately obvious to a young species like ours, still broadcasting our location with naive enthusiasm. It is as if every civilization that grows up looks out at the stars, learns something terrifying or profound, and then quietly turns off the porch light and locks the door. The nature of that shared lesson is what we must decipher. Does the silence reveal a universe where resources are so precious that advertising your presence invites conflict, as the dark forest theory warns? Or does it show that the ultimate use of intelligence is not expansion, but introspection, a turning away from the physical frontier toward inner frontiers of mind and simulated experience? The very consistency of the outcome, if true, suggests that the path of a technological species is not random, but follows a predictable arc, one that leads away from the noisy, visible struggles of adolescence toward a quiet, sustainable maturity. For us, this transforms the great silence from a puzzle into a curriculum. We are observing the graduate-level behavior of civilizations that have survived their own technological adolescence. Their universal quiet is not a rejection of curiosity, but perhaps its highest expression, a collective decision to minimize risk and maximize understanding in a universe that may be far more perilous or far more subtle than it appears from our vantage point. This hidden consensus among cosmic elders would mean the universe operates with a set of rules we have not yet been taught, written not in stars but in the strategic absence of their light. Perhaps the most honest answer to this cosmic riddle is that no single explanation can fully contain it. The sheer scale of the universe and the mystery of consciousness itself demand a more nuanced view. The profound quiet we observe is likely not the result of one grand filter or one universal policy, but a complex tapestry woven from many threads. Each theory we have explored offers a piece of the puzzle, and when combined, they form a more plausible and perhaps more unsettling picture of our reality. Consider the foundational layer. The rare Earth hypothesis suggests that planets capable of nurturing a long, stable biological journey are themselves extraordinary masterpieces. This cosmic scarcity means that even in a galaxy of hundreds of billions of stars, the number of potential cradles for intelligence may be far smaller than our optimistic math once assumed. Then layer upon that the relentless challenge of time. Civilizations that do arise may flicker into existence separated by tens of thousands of years, their brief eras of radio broadcasts or early spaceflight never overlapping. We are listening during our 1-century window for a conversation where the pauses between sentences last for millennia. Now add the dimension of technological evolution. A society that survives its adolescence may not vanish but simply change channels. It could graduate to forms of communication we cannot perceive, or turn its focus entirely inward to virtual realms or contemplative states, leaving the noisy physical universe behind. And for those who remain active and outward-looking, the lessons of survival might universally advise caution. Whether motivated by the predatory logic of a dark forest or the protective wisdom of a galactic club, the most consistent strategy for a mature civilization could be strategic invisibility. They learn to hide their energy signatures, cloak their worlds, and observe from a distance, adding to the overall impression of an empty cosmos. When you combine these factors, the genuine rarity of suitable worlds, the crushing mismatches of cosmic time, the likelihood of technological transformation, and the possible consensus for silence, the great silence begins to feel less like a paradox and more like an inevitable outcome. It is the product of multiple filters and choices stacked upon one another. We are not just looking for a needle in a haystack. We are looking for a needle that only exists for a fleeting moment, that then learns to disguise itself as a piece of straw in a haystack so vast that light itself takes ages to cross it. This multi-factor framework does not provide a simple, satisfying answer. Instead, it offers a humbling perspective. The universe may not be empty, but the conditions required for us to notice anyone else, and for them to notice us in a mutually recognizable way, are so exceptionally narrow that silence becomes the default state of our experience. Ultimately, the true power of the Fermi paradox lies not in solving it, but in the profound questions it forces us to ask. It is a mirror held up to our science, our philosophy, and our deepest assumptions about reality. The silence we perceive is a vast, open space for wonder, a reminder that the absence of evidence is not evidence of absence. It is instead a compelling reason to look harder, to think more creatively, and to expand the very definition of what we consider a signal. Our search for cosmic neighbors is ultimately a search for ourselves, a quest to understand what intelligence is, what it becomes, and whether our own story is a common chapter or a singular volume in the library of the cosmos. This grand mystery reframes our place in the universe. Whether we are a rare miracle, a young species in a crowded but hidden galaxy, or the universe's first attempt to know itself, our moment of awareness is precious. It carries with it a profound responsibility to nurture that spark of curiosity, to protect our fragile cradle, and to continue reaching outward with both humility and hope. The next chapter of this story is ours to write. It will be written by the scientists who design new telescopes, by the engineers who build new probes, and by every person who looks up at the starry sky and wonders what or who else might be looking back. Stay curious, support the journey of discovery, and keep listening to the beautiful, enigmatic quiet of the cosmos.